Hey guys, I recently wrapped up the build on this Protos 380 and I'm at the field today to do the maiden, but I thought we'd do a build review first just in case it doesn't come down in the same shape that it goes up, right?
You never know on a maiden.
You never know on a maiden, that's right. So I got Freddie with me obviously, and we're gonna take the canopy off and do a first look, and I'll just kind of show you a couple different things on this one that I liked and a couple things I didn't like, and then we're gonna go maiden the plane. Oh.
Heli.
All right, I've got the canopy off and we'll take a little look from the front to the back. And what I'll tell you is that overall, I didn't have no major issues. Everything on the helicopter went together correctly. I didn't have to do any major surgery. I had a couple little annoyances, like in these plastic pieces, they have these brass retaining nuts. And on one of them, it was stripped out. Fortunately, I had some, so I was able to replace it pretty easily. Not too much of a problem. The ESC plate up front works fine with the Hobbywing Platinum ESC that's recommended. Notice they've got that little O-ring belt. Some people don't like O-rings, but I decided just to try it and see how it worked out. I'm using the same exact electronics package in this that I used in the Goblin. So I've got the X-Nova, what is that? It's an 890 kV, right? The X-Nova 890. The pinion up front is a 21 tooth pinion, and I think that's a 120 tooth main gear. And then the tail rotor belt goes to the back, and this is a belt driven tail rotor. I'm using the same KST DS521 servos, the Icon 2 fly barless controller, and the KST DS565X for the tail rotor. So same exact electronics package. This kit did not come with the main blade, so I found some rotor techs online. I think it was Power Heli, and they had them on sale. Normal price is $45, and I found these for $29, so good sale price on those.
That's a real good deal.
Yeah, I'll put a link to that in the description so you can get them if you're interested. So the main differences between the SAB Goblin and the Protos on the head is that you've got this metal hub in the center, and then plastic, right?
Yeah, to save on cost, you know, they go to the nylon blade grips, and also
these.
Yeah, it also actually saves a little bit on weight, believe it or not, too. It's a little less weight in there.
And these are the these are washout. They
call them washout arms. I like to call them follower arms. Personally, but yeah.
So they're plastic on the Protos, and on the Goblin they were aluminum or metal.
Yeah,
right?
metal.
Swash plate looks good. They look very similar in terms of design, and then. Other than that, you know, the top end, the rotor is pretty much the same. There's not obviously mechanically, there's not a whole lot of difference. I would say regarding the build itself, there wasn't anything particularly challenging about the build. One thing that I'll note is that the servos are kind of tucked inside the frame a little bit. So if you wanted to change the horn, say you had a crash and need to change the horn, it's a little more problematic on this frame than it was on the Goblin. On the Goblin, they were just more accessible, easier to get to. And the servos were arranged kind of around the airframe. In this design, they've got the two servos in the back and then one servo over here on the port side of the fuselage. And then on the back end, you've got the KST servo. That's exposed. It's on a servo mount out here. This one obviously has boom supports. You need JB weld to epoxy those in. I've got my R161 receiver right here down on the bottom running F-port to the Icon. Okay, regarding the tail rotor, everything back here went together fine in terms of the mechanics, but I do have one gripe in my kit. My blade root on the tail rotor blades was 5mm and it needs to be 2.5. I ordered replacements from Heli Direct and got them in a few days. I'm sure that's not a normal thing. It was probably just a mistake in packing on mine, but my blade root was 5mm, way too thick for that blade grip. Just didn't work. And then you've got on the bottom the push rod for the servo, the tail rotor servo, back to the tail rotor, and that is a carbon fiber piece with some aluminum. By the way, little pro tip on building, that little metal piece worked really well to install the bearings on the tail rotor hub. It worked perfectly. You can stack the bearings right there on the metal part and then run it right through the blade grip, and it worked like a champ. Drove them in nice and straight. And that cone kept the bearing, the main bearing, from sliding down onto the metal. So just a little pro tip, if you're building one of these and you need having a problem getting those bearings into the blade grip, that's how I managed to get mine done.
Yeah, I like them little metal ends on the push rod also, because it has a cup where the push rod goes into a metal cup as opposed to threads going inside hollow tube that can help prevent, you know, splitting. Sometimes you have issue with your push rod, it will split on the ends.
The carbon fiber tube.
Yeah, and come loose. The cups prevent that from happening.
It does seem to me like there's more surface area for the epoxy on this than there is on the threaded rod going inside, right? There's a lot more surface area.
Exactly.
So much bigger diameter. So yeah, that's a nice little touch. And then regarding wire management, this is one thing that was a very pleasant surprise on this one. There's a channel between the tail rotor housing and the frame that's free of the belt. So you can take your servo wires and just run them right down to the inside of the frame. They're all sitting right back there, but it winds up giving a very tidy wiring appearance. So nice and clean wiring arrangement on this one. It was actually easier to do the wiring on this than it was on the buddy. And then up front, I just want to point out the way I did my ESC setup, because we had some discussion on this and a couple guys produced some pictures on Discord. I have my motor wires for the ESC coming out the front and running right into the motor, and then on the back I've got the signal lead for the ESC going along the frame back to the controller, and I have my battery lead egressing the port side of the fuselage, so that way when I put my battery on, it's a nice simple connection and it keeps the wires nice and close to the frame when you put the canopy on. One other thing I'll point out is the skids have these little clips for the antenna wire, and I wound up putting a little bit of CA glue on that gap, but just enough to hold the wire in, and I can still get it out if I need to do a repair or whatever. So nice little touch on the bottom. And then notice the motor egress is right here on the bottom as well. Not very easy to do any kind of motor maintenance or service if you need to take it out. You're going to be taking a lot of stuff apart on this helicopter to get access to that motor. So other than that, I think overall the kit went together very well. I didn't have to do any major operations. All the parts fit together perfectly. The main rotor head went together well. Everything feels smooth, and everything worked within tolerances. No shimming, no cutting, no surgery. I really just didn't have to do any work on this helicopter for the build. Okay, regarding the canopy, Freddie's got a few comments about the canopy. Do you want to point that stuff out, what you were talking about?
Yeah, these are, you know, cost-effective canopies. They're trying to keep the price of cost for the kids down. These are what, just the Lexan?
Lexan, like on the cars, the off-road buggies and stuff.
Yeah, the same thing. They put these same material on the micro heli canopies also. I believe the 480 has this same design material that they use. I mean, it keeps down on weight, it keeps down on price, but you're going to end up with some cracking and stuff like that eventually. A lot of times what I do, if I have on my micro helis that have these Lexan canopies like this, is I actually tape off all the edges, tape off the whole front, and I will get the Plasti Dip clear spray, and I will spray a couple coats on the inside. And I mean, it adds
keeps
a
it from
little
scratching up. Well,
it gives you a little bit of weight. It protects your paint from scratching. This might be in the plastic itself, but mostly if you get a crack, it'll hold it together. Okay. Is the point that I do it for. You don't, you know, you get a crack and it's just going to start running all the way across. And eventually, it's going to split. But if you put the Plasti Dip spray and inside, you get a little crack, it won't, you know, continue to run. It won't flop around and, you know, get looser and looser.
Neat, good pro tip. Thanks, Freddie. That's a good tip. I love tips like that. All right, guys. Well, there you go. That's the build review on the Protos 380. I hope you enjoyed the content. If you like this kind of material, make sure you hit the subscribe button and the notification bell so you know when new material hits the channel. That's all I've got on the build review. Say goodbye, Freddie.
Later, folks.
Take care, guys. Hey, if you like the work I do here on RC Video Reviews, please consider joining me on Patreon. For about the price of a cup of coffee, you can help me keep making videos just like this one. If you'd like to help out, there's a link in the description and on your screen.